In this second lesson on radians, we're going to have a quick look at solving trig equations, which is something that we've already done in the Year 1 content, but giving our answers in radians and thinking about the trig graphs in radians rather than in degrees. So this should all be recapping, but it's a really important skill, so it gives you another chance at practicing it a bit more as well. So the first thing to think about is, what do our trig graphs look like, but in radians rather than degrees? So let's just start with sine. Now sine normally, I say normally, in degrees, would look like this. And we would have 0, 180, and 360. However, in radians, we need to change this. So obviously 0 is still going to be 0. Instead of 180, we're going to have pi. And instead of 360, we're going to have 2 pi. You might want to add on some extra points here and here, talk about where the maximum and minimums are. So this point here that would normally be at 90 degrees, this is going to be at pi over 2. This one here, which would normally be at 270, well, this is halfway between 1 pi and 2 pi. So this is 1.5 pi, or 3 pi over 2. Okay, and this is for sine theta. So this obviously changes the rules for finding multiple solutions. Rather than doing 180 minus my answer, I'm going to be doing pi minus my answer. The period of the graph is still the same, but instead of 360 degrees, it's now 2 pi. So we could do 2 pi plus my answer to find multiple solutions that way too. If we do the same for cosine, let's draw that a bit straighter, shall we? Not sure why it came out so squiffy. Okay, so for cosine, key points here, here, I suppose here, and here. At the end, instead of 360, it's 2 pi. Halfway, it's going to be pi. Back here is 0. So this point here that was 90 is pi over 2. And this point here that was 270 is 3 pi over 2. Okay. Now, in terms of your rules for finding multiple answers here, this is for cosine theta. What we did in degrees was 360 minus our answer because we used this symmetry here and here. These were the same distance. So instead of doing 360 minus, we're going to do 2 pi minus our answer. And of course, we can do add 360, or in this case, add 2 pi. Okay, so we can use those rules. Also, we can still use the symmetry of the graph like this. So for example, if we had a solution here, we would also have one here. If we had one at, I don't know, pi over 6, we would also have a solution at minus pi over 6, because cos is what you call an even function, so it's symmetrical about the y-axis. For the tan graph, normally I start when I draw tan by drawing the asymptotes on first. That tends to help me. In degrees, my asymptotes are at 90 and 270. So in radians, they're going to be at pi over 2 and 3 pi over 2. And then I normally use this to draw in my graph. Okay, so the shape is the same, it's just the axes that are changing. This point here would be pi, this would be 0, and this would be 2 pi. With tan, what we would do in degrees is we would add on 180, because the period of this graph is 180 degrees. Working radians, we're just going to be doing plus pi. Okay, so it's all the same ideas, all the same symmetries, it's just that the units have changed essentially. Now let's do a couple of examples of solving equations, just to rejig our memories of it. So we're going to solve these between 0 and 2 pi. The first thing to make sure of in these questions as well is make sure your calculator is set into radians. Okay, if you need to do that, you can do Shift and Menu, which goes into Setup. Okay, and then you can change your angle unit in there. So sine theta equals 0.3. Let's just draw a quick sketch what that looks like. So it looks like that. So I'm expecting 2 solutions here and here. So to inverse sine of 0.3, let's see what we get. We get 0.3. That is just coincidence there. It's really 0.305. Maybe I'll write that to make it clear that it's not just the same. 0.305. And then my next answer could be pi minus that answer. So pi minus that is 2.84 radians. Okay. So next one, 4 cos theta equals 2. Well, that would mean that cos theta equals 1/2. So it would look like this. 2 solutions. So we need to do inverse cos of 1/2. Okay, now in degrees that would be 60 degrees, but here it's going to be pi over 3. That's my first solution. Try the next one, I need to do 2 pi minus that. So 2 pi minus 2 pi minus pi over 3, which is 5 pi over 3. This next one, 5 tan theta plus 3 equals 1. Well, that means that tan theta is going to be 1 minus 3, which is minus 2 divided by 5. So minus 2/5. Tells what that looks like. Minus 2/5 is down here. So we're going to get probably 2 solutions. So my first one I get is minus 0.38, which is down here. Okay, it's where this graph would continue down here. But I can still use the same rules as I'd use normally. So I'm going to add, instead of adding 180, I'm adding pi, remember in radians. So add pi. My first answer is then at 2.76. Add pi again. And that's 5.9. Okay. Now remember it says between 0 and 2 pi. Sometimes it's worth thinking, what is 2 pi? 2 times 3.14 is about 6.28. Okay. So that's worth keeping in your head that 2 pi is about 6 and a bit when you're searching for these decimal answers, because it's not always obvious. Is it bigger or smaller than 2 pi? Right, let's have a look at some that involve identities as well. This is all things that we've done before. If you think you need to go back and review this, maybe go back and watch the videos from the year 1 trigonometry chapter. I think it's chapter 10. So 17 cos theta plus 3 sine squared theta equals 13, and solve it between 0 and 2 pi. So the problem here is I've got sine and cos involved. It needs to just be in terms of one function. So I'm going to change the sine squared using the identity sine squared plus cos squared equals 1. Okay, that was one of our trig identities we had before. What's this? So I can use this to rewrite it as 17 cos theta plus 3 times, and instead of sine squared, I can write 1 minus cos squared theta. Equals 13, and then I can rearrange this. I'm just going to rewrite it as a quadratic. Okay, and once we get to that point, we can either try and factorize it, or we can just use our calculator to solve it. I think I'm just going to use my calculator to solve it. Okay, so when I do that, my 2 solutions that I get are either cos theta. Remember that it's cos theta, not just theta equals. Sometimes people make that mistake. Cos theta equals 5, or cos theta equals 2/3. This first one, cos theta equals 5, well, I don't think there's any solutions to that. Cos theta, remember, just goes between 1 and minus 1. So cos theta equals 5 is a line up here. So there's no solutions to this bit. So I don't need to work any further on that part. Cos theta equals 2/3. Well, there is definitely going to be some solutions to that. 2/3 is here, so I'm expecting 2 solutions. So inverse cos of 2/3, so 0.84. To find the next solution, I need to do 2 pi minus that, because this value here is 2 pi. So 2 pi minus that answer gives me 5.44. Okay, and those would be my solutions there. Okay, last sort of type we can get is a transformed trig equation. Again, there's a couple of ways you can do this. I'd probably recommend doing it as a substitution, but you can do it in quicker ways. Sine 3 theta equals root 3 over 2. Sine 3 theta, hopefully you'll see this as a graph transformation. This is the sine graph, but it has been squashed in the x direction by 3. So whereas before it looks like this, between 0 and 360, or between 0 and 2 pi, it has now got 3 cycles in the same amount of space. So 1, 2, 3, up to 2 pi. Okay, that's what's happened to it. Now we can either do it with a substitution, or we can think about the graph here. I'm going to do it as a substitution first. I'm going to let 3 theta equal phi. So that means that sine phi is root 3 over 2. Now the other thing I need to do is change my limits. Okay, so if 3 theta equals phi, then that means that theta is phi over 3. Like that. So I've replaced theta with phi over 3, and then multiply all sides by 3. Okay, so I can solve this new question in these new limits. Let's go through and do that. So I'm going to do inverse sine of root 3 over 2. And then go through and find my answers. Now I need to go up to 6 pi. So that's my first one. I'm going to do pi minus my answer. Let's find the next one, which is 2 pi over 3. And I'm going to take both of these and I'm just going to add 2 pi onto each of them. So pi over 3 plus 2 pi is 7 pi over 3. And then do it again. That'd be 13 pi over 3. Now remember, I'm going up to 6 pi. So 13 over 3, well, that's 4 and a bit, so I'm still not there yet. 13 pi over 3 plus 2 pi give me 19 pi over 3. Okay, so I think this one's slightly too big, isn't it? 19 over 3. 19 over 3, yes, that's 6 and a bit, so we can't quite have that one. Let's go to this one and find its multiple solution. So 2 pi over 3 plus 2 pi. So to find the answer, which is on the next period, would be 8 pi over 3. Do it again. 14 pi over 3. And if I do it again, I would get 20 over 3 pi, which is going to be too big. So these are our answers for phi. Then we just need to change them back for theta. And theta is going to be this divided by 3. So each of these divided by 3. So that'd be pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. Okay, so I've just divided each of them by 3. So that's one way of getting that. It's a bit more long-winded, but it's quite accurate. And if you just go through the method, you will definitely get to your answer. The other way of doing it, so if I just start with this, okay, is to solve is to find out what 3 theta is. So I can do inverse sine of root 3 over 2, which gives me pi over 3. And then I can divide both sides by 3 to give me pi over 9. That would be my first solution. You can see that works here. But to find the others, I need to remember that this graph has been squashed by 3. So instead of doing pi minus my answer, or 180 minus my answer, the graph has been squashed by 3. So whereas normally I'm using this symmetry here, where this point is pi, I'm using this symmetry here, which is a much, much smaller number. It's 3 times smaller than pi. It's going to be pi over 3. So we're going to have to use pi over 3 minus my answer instead. So I'm going to do pi over 3 minus pi over 9, which is 2 pi over 9. And then to find the rest of the answers, instead of adding on 2 pi, so instead of adding on 360, because normally the period of this graph is 360 or 2 pi, Well, now the period is much shorter than that. Now the period is 3 times smaller than that. So instead of being every 2 pi, it's every 2 pi over 3. So we could do 2 pi over 3 plus our answer. Okay, these would be the two ways of doing it here. So I can do pi over 9 plus 2 pi over 3 to get my next one, which would be 7 pi over 9. And then I could do it again and get 13 pi over 9. And I could do the same for the other ones, and you can see that I'd get the same results. Okay, so there's two different methods here, one by substitution and one by doing it considering how your graph has changed. Now the second method is probably quicker if you've got something nice in here. If this was something really awkward like 2.87 theta, then that's not quite as nice to think about how your symmetries have changed. But if it's 3 theta or 2 theta or something like that, then that's quite easy to think about. Okay, so two different methods there, and it's good to be able to do both of them. So what you can do now is you can look at exercise 5e in the book, which is in the Radians chapter, but it is just more practice of what was in the year 1 content. I would recommend that you focus on maybe questions 10 to 15, which are the exam ones, but there's plenty of other ones in there if you just need a bit of practice.